Hello students, welcome back. Today we will start the unit 3, the relational query language. Now the relational model was introduced by Dr. E.F. Code in 1970. In the relational model, the data is organized in two-dimensional tables called relations. The tables or relations are however related to each other. Each table represents some real-world entities or things. The organization of the data into relational tables is known as the logical view of the database. The relational database is a collection of data items with predefined relationship between them. These items are organized as a set of tables with columns and rows. The tables are used to hold information about the objects to be represented in the database. Each column in a table holds a certain kind of data, and a field stores the actual value of an attribute. The rows in the table represent a collection of related value of one object or entity. Each row in a table could be marked with the unique identifier called as a primary key, and rows among the multiple tables can be made related using foreign keys. This data can be accessed in many different ways without recognizing the database tables themselves. Okay, this is the example of the relational model. Here we are seeing that the first one is a department table, the second one is a professor tables, the third one is a course tables, and the last one is a student table. In the department table, the number is a primary key, and the professors the department number field is a foreign key that represents the primary key of the department. And the second one is the course tables, the number is a primary key of course tables, and in professors tables the courses is a foreign key of that table. And this is the example of relational model representing the university. Now relational database definitions. A relational database, it means a set of relations. The relation made of the two parts. The first one is an instance and the second one is a schema. Now it means what is the instance? Instance means a table with the row and columns. When the row represents the cardinality and the field represents the degree. And the second one is schema. A schema is a specifies name of relations plus name and type of each column. For examples, the students, the student ID is a string, the name is string, the address is string, age is integer, and the GPA is real. Okay, this is the specifies name of relations plus name and data types. We can think of relation as a set of rows and tuples. All rows are distinct. Now what is tuple? Now first of all, what is table? In relational database model, a table is a collection of data elements organized in terms of rows and columns. A table is also considered as a conventional representation of relations. But a table can have a duplicate row of data, while a true relations cannot have a duplicate data. Table is the most simplest form of the data storage. Now the next is a tuple. A single entry in a table is called a tuple or record or row. A tuple in table represents a set of related data. The next one is an attribute. A table consists of several records. Each record can be broken down into several smaller parts of the data known as attributes. The next one is a cardinality. So we have seen that the cardinality means rows. The number of rows we have represented, it means a cardinality. And the next one is a degree. The degree means the fields. The fields of that tables represents the degree. And the next one is a domain. When attribute is defined in a relation, it is defined to hold only a certain types of value, which is known as attribute domain. Hence the attribute name will be hold the name of employee for every tuples. Now this is the example. Here we have seen the number of columns is 4, the EN number, name, department, SAM and SPS, sorry, 5. Okay, and the number of row is 3. First one is a Raj Patel, the second one is a Megha Waghela, and the third one is Akshay Patel. Okay, here the cardinality means number of row, it means 3, and the degree means the number of fields, it means number of columns, it means 5. Now major components of relational model. The relational model consists of 3 major components. The first one is a set of relations and set of domains that defines the way of data can be represented. It means the data structure. What is the structure of this data? That's the first major components of the relational model. The second one is integrity rules that define the procedure to protect the data. It means the way of sets the some integrity rules to that relations. And the third one is operations. It means the data manipulations, the operations that can be performed on the data. A relational model database is defined as a database that allows you to group its data items into one or more independent tables that can be related to one another by using fields of common to each related table. Now properties of relational table. The first one is the all values are atomic. The second one, each row is unique. The third one is the column values are same kind. The sequence of column is insignificant. The next one is the sequence of row is insignificant. Each column has a unique name. Now the first portion on the is a primary key, the main portion, the main part of the relational model. Now what is a primary key? Primary key is a column in a table that uniquely identifies the rows in a table. For example, here we have seen that this is the customer table. For example, in this table the customer number is a primary key. The value are placed in primary key column must be unique for each row. No duplicates can be tolerated. In addition, the nulls are not allowed in a primary key columns. Okay. The primary key can't accept the null values. Now the next is a foreign key. The foreign keys are columns that point to primary keys to columns. Okay, here we have seen that the order number, the customer number, company and price, and the customer number is a foreign key of this table, and this is denoted to or points to the customer table's primary number. For example, order number is the primary key of the table orders, and below the customer number is a foreign key that points the primary key in the customer's table. Now this is the examples, or we have to create these tables using the primary key as well as the foreign key. Okay, the first one is a create table customers, customer ID, integer not null, customer name, varchar, and the constants. Here we have add the constant as a primary key, the primary key in brackets customer ID. Now foreign key, the create table order, order ID, integer not null, amount, integer not null, customer ID, integer. Now for the foreign keys, the foreign key customer ID, a reference to the customer's customer ID on deletes cascade. Okay, यहाँ पे ये चीज़ क्या है, ओके वो अभी आपको जानना जरूरी नहीं है, बट हाँ यहाँ पे हमने फॉरेन की कैसे डिनोट की और फॉरेन की हमने की सिंटेक्स क्या है वो हमें ध्यान रखनी है. ओके, विद द हेल्प ऑफ रेफरेंस कीवर्ड we have point out the primary key of that table. Okay, foreign key customer ID, reference is customer's customer ID. ओके, यहाँ पे आपको एक चीज़ ध्यान रखनी है कि हाँ यहाँ पे कस्टमर आईडी है, उसकी डेटा टाइप इंटीजर है, तो जो मेन जो हमारा टेबल है वहाँ पे भी उसकी डेटा टाइप कंपलसरी इंटीजर ही चाहिए. दोनों वैल्यू, दोनों की डेटा टाइप सेम होगी तो ही हम रिलेशंस क्रिएट कर पाएंगे. What's the difference between the primary key and foreign key? The primary key uniquely identifier record in the table. On the other side, the foreign key is a field in the table that is a primary key in the another table. Primary key can't accept the null values. In other words, the foreign key can't accept the multiple null value. By default, the primary key is a clustered index, and data is in the database table is physically organized in the sequence of clustered index. On the other side, the foreign key not automatically create an index, clusters or non-clusters. You can manually create an index on foreign key. We can have only one primary key in a table. We can have more than one foreign key in a table. Now, what is attributes? The entity is represented by a set of attributes, that is descriptive properties possessed by all members of an entity sets. Okay, this is the examples, the TBL customers and the TBL loan. Okay, the TBL customer and the TBL loan is an entity, and these are the attributes: the customer ID, customer name, customer street, customer city. And the TBL loan entity having the two attributes. The first one is the loan number and the second one is the amount. Now, what is domain? A domain definition specifies the kind of data represented by the attributes. A domain are the set of allowable data values for a column. It means the constants. For example, the pin code 6 digits column with the customer entity can be integer domain, as such as the database would not allow you place like 123.45 or floating point or a character into that column. It only covers integer data. Now the next one is a tuple. A single row of table which contains a single records for that relation is called a tuple. For examples, our account table, we have three attributes: the branch name, account number and balance. Let's see, the first one is a D1 is equal to set of all account numbers, D2 is equal to set all branch name, and the D3 is equal to set of all balance. So row of account table must contain the three tuples V1, V2 and V3. Well, the V1 is equal to account number in the domain D1. V2 is equal to branch name in the domain D2, and the V3 is equal to balance in the domain D3. Okay, so these three are the tuples. Therefore, the account is a subset of D1 cross D2 cross D3. Okay. To generalize the table of n attributes, must be a subset of D1 cross D2 cross D3 up to Dn minus 1 cross Dn. Okay, this is a table. So finally, a relation is a Cartesian product of list of domain which corresponds to our definition of the table. A relational consists of the relational schema and a relational instance. Now, what is relational schema? A relational schema describes the relational name. It means the table name, attributes and their names. A finite set of tuples in the relational database system represents the relational instance. The relational instance do not have a duplicate tuples. Here the four examples. We have seen that these are the four columns: the year number, student number, student age, student city. These are the four attributes. The first one is the year number, the second one is the student name, the third one is the student age, and the fourth one is the student city. And here these are the domains. The year number has 4 digits, student name has a strings, the student age is a minimum is a 18, and the student city and the Vadodara, etc. This is the primary key of this table, year number, and these are the domains. Already I have told that. The next is a tuples. Tuples means the number of rows. Okay, here you have seen that there are the 4 tuples, and this is the cardinality, and these are the attributes, and this is the degree of this table. So this is called the relational model or relational database model. So now the next is the equivalent database concepts. Okay, so relational and the tables. The tuple means the row or records. Attribute means the column or field. Cardinality means number of rows. The degree means the number of columns. The primary key, it means the unique identifier of these tables. And the domain, the pool of legal values. Now the relational algebra. A relational algebra is one of the two formal query language associated with the relational model. Queries in the relational algebra are composed using a collection of operators. Every operators in the algebra relations instance as arguments and return a relation instant as a result. An operator can be either a unary or binary. A relational algebra is a procedural query language which takes an instance of relation as an input and yields instance of relation as output. They accepts the relation as their input and yield relations as their output. The relational algebra is performed recursively on a relations, and intermediate results are also considered as a relations. The fundamental operations or basic operations of relational algebra. The first one is a select, the second one is a project, the third one is a union, the side different, Cartesian product, and rename. These are the basic operations. The first one is selection operations. The select a subset of rows from a relations. Select a subset of rows from a relations. Its sign is a sigma. Symbol is a sigma. Now the next is a projections. Select a subset of columns from the relations. This symbol is a pi. The next one is the cross product. Allow us to combine the two relations. The symbol is a cross or multiplications. The next one is a side difference. The tuples in the relation 1 but not in the relational 2. The symbol is a minus. The next one is a union. The tuples in relation 1 and relation 2. And the symbol is a U, union. And the next additional operations are the intersections, the join, divisions, and renaming. Not essential but very useful. Okay, since each operations returns a relations, operations can be composed. Okay, so now we have seen the one by ones. The first we will see a selection operations. Now the selections. The selection returns a subset of the rows of a single data. The syntax is the select table name where conditions the column name from the indicated tables. Alternately, for the relational algebra syntax, okay, the first syntax is a mass equal syntax, and the second one is a relational algebra syntax. The sigma conditions or column name, then small brackets the table name. Then let's see, we have seen the this is the supplier. Okay, supply tables. We have 3 columns. The first one is the serial number, the second one is a serial name, and the third one is the locations. Now the question is to find the all suppliers from the Boston. So now the select star from supplier where location is equal to Boston's. Okay, this is the MySQL query, and the relational algebra syntax क्या होगी हमारी? Sigma location is equal to boss. The table is a supplier. Okay, so this is the resultant of this relational algebra or relational query. Sigma location is equal to Boston's and bracket supply tables. Okay, तो ये सिलेक्शन ऑपरेशन हम कहाँ पे यूज़ करेंगे? तो रिटर्न सबसेट, और सपोज हमें नंबर ऑफ रो चाहिए. ओके, तो नंबर ऑफ रो एक्वायर करने के लिए या फेच करवाने के लिए हम कौन सा ऑपरेशन यूज़ करेंगे? सिलेक्शन ऑपरेशन यूज़ करेंगे. ओके, now once again we have seen the second examples. Okay, this is the card holder tables. Here we have seen the four columns: the borrower, borrower name, borrower address, and borrower status. Find the card holders from Modena. Okay, तो यहाँ पे उसका first one MySQL syntax क्या होगा? The select star from card holder where B address is equal to Modena, and the relational algebra syntax, the sigma B address is equal to Modena, and the table name is a card holder. Now here the observation of this syntax, there is only one input table. Both card holder and the answer table have the same schema. Okay, and every row in the answer has the value of Modena in the table B address columns. Now this is the result. Okay, this is the same schema, and the another one is a result and is also the same schema. The all rows in the answer have the value modena in the B address column. Now the next one is a projection. The projection returns a subset of the columns in a single table. Projection returns a subset of a column in a single table. Okay, यहाँ पे ये क्या रिटर्न करेगा, कॉलम. वहाँ पे जो सिलेक्शन ऑपरेशन था वो क्या रिटर्न करता था, नंबर ऑफ रोज. और यहाँ पे प्रोजेक्शन क्या करेगा, कॉलम. उसकी सिंटेक्स क्या होगी, प्रोजेक्ट टेबल नेम ओवर लिस्ट ऑफ कॉलम्स. Alternatively, in relational algebra syntax, the pi list of columns then table name. Let's take the example here. Since the table is a supplier, to find the all suppliers name, project supplier over serial name. Now pi as name supplier, यानी हमें ऑल सप्लायर के सिर्फ नेम ही चाहिए. ओके, तो उसके लिए हम क्या करेंगे, सिर्फ हमें एक ही कॉलम चाहिए, ये वाली सीरियल नंबर वाली. ओके, then pi serial name is equal to bracket supplier pi serial name supplier. ओके, तो रिजल्टेंट क्या आएगा हमारा, दिस आ जाएगा, ओनली एस नेम और सप्लायर नेम. The next example, find the addresses of all card holders. Okay, the project card holder over B address. Alternatively, pi B addressed table name card holder. Okay, so there is only one input table. The schema of the answer table is the list of columns. If there are many card holders living at the same address, these are not duplicated the answer table. Now the next is a Cartesian product. The Cartesian product of two sets is a set of pairs of elements, one from each sets. If the original sets are already sets of tuples, then the tuples in the Cartesian products are all that bigger. The syntax is the table name 1 cross table name 2. This is the syntax of Cartesian product. The Cartesian products are usually unrelated to a real world thing. They normally contain some noise tuples. However, they may be useful as a first step. Okay, now let's check the examples. Here we have the two tables. The first one is a supplier and the second one is a part. Now below is the resultant table of the supplier cross part. Okay, so this is the Cartesian product of supplier and part. But here you have seen that some of the noise occurs in the 7 rows in a total. And the noise 30 rows in a total. Okay, so here the noise occurs in this the resultant table. Now let's check the another examples. The names is equal to project card holder over the B name, and the address is equal to project card holder over the B address. It means we have names cross addressed. Okay, so now the next is a union. A union is used to combine the results of two or more select statements. However, it will eliminate duplicate rows from its result state. The syntax is the table 1 union table 2, and the table 1, alternatively we have used table 1 u table 2. Okay, this is the Venn graph of the union. Okay, this is our result of union. This operation is impossible unless both tables involved have the same schemas. Why? Because the row from the table must be fit into a single answer table. Hence they must look alike, because some rows might already belong to the both tables. Okay, here you have seen that the Venn graphs. Okay, it means यहाँ पे हमें टेबल 1 और टेबल 2 की जो कुछ चीज़ें हैं, कुछ कॉलम्स हैं, वो सेम ही चाहिए, सेम स्कीमा में ही चाहिए, तो ही हम यूनियन ऑपरेशन कर पाएंगे. Let's check the examples. Okay, part 1 suppliers and part 2 suppliers. Okay, इसका हमें यूनियन चाहिए, तो हम क्या करेंगे, पार्ट 1 सप्लायर्स यूनियन पार्ट 2 सप्लायर्स. अल्टरनेटिवली हम क्या यूज़ कर सकते हैं, पार्ट 1 सप्लायर्स इज इक्वल टू पाई सीरियल नंबर सिग्मा पाई नंबर इज इक्वल टू P1 द सप्लायर्स. ओके, एंड this is the Part 2 suppliers is equal to pi serial number, sigma pi number is equal to P2 supplies. Here this is the answer. Part 1 suppliers union part 2 suppliers. Okay, let's check the another examples. Okay, of this example, the part 1 suppliers having a 3 rows, the serial number S1, S3 and S4. Now the part 2 suppliers having the S2 and S4. Now we have checked the union operations. Now the resultant is a 4 rows. Okay, यहाँ पे डुप्लीकेट वैल्यूज क्या हो जाएगी, रिमूव हो जाएगी. Now let's check the another example. Find the borrower numbers of all borrowers who have either borrowed or reserved a book. Okay, find the borrower numbers of all borrowers who have either borrowed or reserved book. Let's check the two tables. The first one is the borrower tables and the second one is the reserve tables. Okay, so now the result is borrowers union reserves. Reserves is equal to pi borrower ID reserves. The borrowers pi borrower ID borrowers. So answer is the borrowers union reserves. Okay, so this is the answer of the borrowers union reserves. तो यहाँ पे आप चेक कर सकते हैं कि जो डुप्लीकेट वैल्यूज थी वो क्या हो जाएगी, रिमूव हो जाएगी. The duplicate values remove हो जाएगी. Now the next one is intersections. Intersection operations is used to combine two select statement, but it only returns the records which are common from both select statements. MySQL does not support intersection operators. This is the syntax. The first table 1 intersection table 2. Alternatively, we have used table 1 intersections operator table 2. Okay, this is the observations. This operation is impossible unless both tables involved have a same schema, because rows from the both table must fit into a single answer table. Now let's check the examples. We have seen the part 1 suppliers and the part 2 suppliers. Okay, the part 2 suppliers having a three rows and the part 2 suppliers having a 2 rows. Okay, S1, S3 and S4. And here the part 2 supplier having S2 and S4. The resultant is a part 1 supplier intersect part 2 supplier. तो यहाँ पे रिजल्ट क्या आएगा, ओनली S4. ओके, जो कॉमन थिंग्स होगी या कॉमन वैल्यूज होगी वो ही इंटरसेक्ट करके हमें आंसर मिलेगा. इंटरसेक्शन ऑपरेटर में ये होगा. नाउ लेट्स सी द अनदर एग्जांपल्स. फाइंड द बोरोवर नंबर्स फ्रॉम ऑल बोरोवर्स हु हैव बोरोड और रिजर्व बुक्ड. Okay, तो आंसर इज द बोरोवर्स इंटरसेक्ट्स रिजर्व्स. ओके, यहाँ पे हमने कौन सा ऑपरेटर्स यूज किया, एंड. वहाँ पे कौन सा था, और. ओके, एंड में क्या होगा, इंटरसेक्शन ऑपरेशन होगा, और में क्या होगा, यूनियन ऑपरेशन. ओके, तो ये चीज़ हमें ध्यान रखनी है. उसके एग्जाम्पल देखेंगे तो एग्जैक्टली आपको पता चलेगा कि ये सारे ऑपरेशंस है वो हम कैसे यूज़ करेंगे. ओके, अभी हम क्या कर रहे हैं, जस्ट गो थ्रू कर रहे हैं जितने भी ऑपरेशन है रिलेशनल अलजेब्रा में. नाउ द लेट्स चेक द एग्जांपल्स. फर्स्ट वन इज अ बोरोवर्स एंड द सेकंड वन इज अ रिजर्व्स. ओके, तो यहाँ पे हम जो इंटरसेक्शन ऑपरेशन वो अप्लाई करेंगे तो जो कॉमन थिंग्स होगी, कॉमन वैल्यू होगी, वही आंसर आएगा. तो फर्स्ट क्या आएगा, 1325 2653 7635 एंड 9823. ओके, नाउ आज के लिए इतना ही. नेक्स्ट लेक्चर में हम जो भी ऑपरेशंस बाकी रहे हैं वो हम देखेंगे. ओके, इसके जो क्वेश्चन है वो मैं बाद में दे दूंगा. ऑलरेडी मैंने असाइनमेंट 1 दे दिया है, उसके लास्ट डेट भी मैंने ऑलरेडी गूगल क्लासरूम में मैंने नोटिफाई कर दी है. कुछ भी क्वेश्चन है तो आप मुझे व्हाट्सअप या गूगल क्लासरूम में पूछ सकते हैं और मेल के थ्रू भी पूछ सकते हैं. थैंक यू. Here the resultant is a Cartesian product is a names cross addressed. So here you've seen that this is the noise of resultant Cartesian product.